Okay, so you're welcome to this class. All right, this class is a class on photoelectric effect. Okay, so what is photoelectric effect? All right, photoelectric effect is actually a way, all right, of generating electricity using the sunlight. Photoelectric effect is the process of generating electricity using the sunlight. Okay, that being said, if you subject, all right, a metal plate to the sunlight, all right, what's going to happen is that the sun emits a radiation on the surface of the plate. Okay, now, and as it emits radiation on the surface of the plate, what happens is that there is ejection of electron from the metal plate. There is ejection of electron from the what? Metal plate. So the energy, all right, that the sunlight, that light is traveling with, is what it calls photon. Photon. E. All right, that is photon. Now, the energy required to move the electrons from the surface or to eject the electrons from the surface of the metal is what we call the work function. All right, and of course, the energy it is moving with is energy in motion. That is kinetic energy. So we have three kinds of energy. We have the energy of the sunlight, which is energy of the photon, all right, because photon means light, all right. A discrete particle of light is what we call photon. Then the packet is what we call quantum. Okay, quantum. So if that is the case, my ME is the what energy of the sunlight. W naught is the work function, which is the energy required to eject the electrons from the metal surface. Then K is the what energy that the electrons are moving, all right, with. So these three energy were connected together by what we call Albert Einstein equation or Albert Einstein energy equation. Which says that Albert Einstein energy equation says that energy of photon is equal to work function plus kinetic energy. All right. So EK, we can say E of the K. So E is equal to energy of photon. Energy of photon, all right. W naught is equal to the work function, and EK is equal to the kinetic energy. So if that is the case, so these three relationships were connected together by E. So E is equal to, all right, W naught plus what? Plus EK. Now, what is your energy of photon? Now, your energy, all right, is energy of photon is directly proportional to the electromagnetic frequency. Okay, the frequency of what? Of radiation. So if E is proportional to F, what's going to happen? I'm going to introduce a constant, so I have E is equal to KF. But my K in this context is H, which is we call the what? Planck constant. H is equal to the Planck's constant. Planck's constant. So if that is the case, I have E is equal to, anywhere I see K, I'm going to be writing H. All right. So energy of photon is equal to what? HF. So Planck constant multiplied by the electromagnetic frequency, all right, or the frequency of the light is what we call what? The energy of photon. So E is equal to HF. If E is equal to HF, so now let's move to the work function. Now, this is the first. Now, work function is given to what? To be HF, because it's an energy, all right? It's also HF. But when you come to your HF, your F at the work function is F naught, which is called the threshold frequency. So the best value for F for W naught, which is the work function, is HF naught. Okay. Then this work function, this is the Planck constant, and this is the threshold frequency. Threshold frequency is actually the frequency, all right, that the electrons that were ejected from the metal surface, all right, moved by. So those are the frequencies, or you can call it the frequency needed to eject an electron from the surface of a metal. We call it threshold frequency. So F naught here is called threshold frequency. Threshold frequency. All right. So if that is the case, so I have my W naught is equal to HF naught. Okay. So now, according to the law of light, all right, of wave, because light can actually exist as an energy and can exist as a particle, all right, or as a wave. That when you talk about the concept of wave particle duality, you are actually considering light as two things. Light, first of all, as a particle, and light as a wave. So if my W naught is equal to HF naught, I'm going to be having my C, all right, because we said V is equal to F lambda, all right. So if my V here is the value of C, all right, so I have C is equal to F lambda. Where is my C? C is the speed of light, F is the what? Frequency of wave, then lambda is the wavelength. If my C is equal to F lambda, what is the value of F? F is equal to C over what? Over lambda. So if F is equal to C over lambda, I have W, all right, HF naught already. So I'm going to be having W naught is equal to H. What is my F naught? F naught is C over lambda. That is now H C over what? Over lambda. My lambda will now be lambda naught. All right. So if this is threshold frequency, this one is going to give us what? Threshold wavelength. So we have lambda naught is equal to threshold what? Threshold wavelength. So at the end, my two formulas for work function is given to be W is equal to HF naught, and the second formula is given to be W is equal to HC over what? Lambda naught. Planck constant multiplied by the threshold frequency, then we have W is equal to Planck constant, the speed of light, over the threshold what? Wavelength. So those are the two values of what? Of threshold what? Of a work function, which are the is the energy, or defined as the energy required to eject an electron from the surface of the metal. Quite important. So now let's move to the next part. Okay, now the kinetic energy. I'm analyzing the three kinds of energy. So the next one is what we call the kinetic energy, EK. All right, EK in physics, what is K? K is equal to what? 1 over 2 what? mv squared. So we have EK is equal to 1 over 2 mv squared. So this mass becomes the mass of electron. In atomic structure, we said mass of electron is given to be 9.11 times 10 raised to power minus 31. So I'm going to be having kinetic energy is equal to 1 over 2. My m here will now become m of the electron. So I have 1 over 2 m of the electron, then v squared. All right. Now there is something that's going to happen in this place. All right. This is the kinetic energy in the electron. Kinetic energy is equal to 1 over 2 mass of electron, then the speed of light, all into square. So if I add all the three things together now, my equation is going to turn out to be you know, I said I have energy is equal to work function plus what? Plus kinetic energy. So I'm going to be having, what is my E at first? My E at first is HF. So I have HF, Planck constant multiplied by frequency is equal to, what is my work function at first? That is what? HF naught. Plus what is my kinetic energy? 1 over 2, then ME and what? And V squared. So if I move on, if I can have C over lambda, all right, at that point, that means in this place, I can also have E is equal to what? HC over what? Over lambda. So I can have HF here to also be what? HC over what? Over lambda. Then this is my threshold frequency, which is defined as the frequency needed to eject the electron from the surface of the metal. So I'm now going to be having it as HC over, it will be in terms of the threshold wavelength, all right? Then plus what is left? 1 over 2 ME and what? And V squared. This is the equation, all right, of Albert-Einstein equation when you transform it. Now, I want to show you something. Once my EK is equal to this, there is what we call stopping potential. All right, there is stopping potential and there is what we call accelerating potential. So, what's going to be the stopping potential? The stopping potential is actually the potential we need to trap, all right, these electrons from not escaping from the surface of the metal. All right, so if you need to trap this electron from escaping, because these electrons were moving with what? A particular magnitude of kinetic energy. So if you want to trap them from not escaping, you will actually balance a particular potential with it in such a way that it will be equal. If the potential, stopping potential is equal to the kinetic energy, then there's not going to be what? An escape of the electron from the surface of the what? Metal. The electrons ejected. So I'm going to be writing my stopping potential E Vs, because it's supposed to be the energy in the what? In the potential is equal to the kinetic energy. This is the only thing that can happen for the electrons not to escape from the surface of the metal, because the energy that is required, right, that is needed in the what? In the potential, so must be equal or must be greater than the what? Kinetic energy for the electrons not to escape from the surface of the metal. So if my E is greater than or equal to Ek, so what is my E? E is equal to Ev. All right, the electronic charge multiplied by the potential, and the potential there is what we call the stopping potential. So I have E is equal to E then Vs. All right. So anywhere I see here, I can write it as what? EV stopping potential is equal to Ek. All right, but your Ek is equal to 1 over 2 MeV squared. So I have EVs is equal to, anywhere I see Ek, I'm going to be writing it as 1 over 2 MeV squared. Okay, then let's assume that I'm looking for my stopping potential. If I'm to calculate stopping potential, I have what? Stopping potential is equal to what? 1 over 2. Okay, all of this 1 over 2 MeV squared is the kinetic energy, then over what? Over E. or Vs is equal to 1 over 2 me v squared over what? Over everything over 2. Alright, then we have everything over A. This is what we call the stopping potential of the electron, Vs. Alright, stopping potential. Vs equal to 1 over 2 me v squared over the electronic charge. Okay, so that is the values, alright, we have for the first theorems we have in photoelectric effect. So my energy of photon is equal to hf, and E is also hc over lambda. Alright, work function, alright, which is the energy required to eject the electron from metal, is hf naught, Planck constant multiplied by the pressure frequency. Then W is equal to hc over lambda naught. Then W, okay, that is that. Alright, those are the two formulas. Then our kinetic energy is given to be 1 over 2. I said this one is mass of electron square. Then we can have our what is it called? Stopping potential is equal to we have energy is equal to EV. This EVS, and your Vs is what? The kinetic energy over the what? Over the electronic charge, which is stopping potential is equal to your kinetic energy is 1 over 2 me what? MeV square. And everything over the electronic charge. So these are the first outlines, alright? Then your F naught is threshold frequency, which is defined as the frequency needed to eject the electron from surface of metal, while lambda naught is the what? Threshold wavelength, which is defined as the wavelength needed or required to eject the electron from the surface of the metal. Alright, so that is that basically. Thanks for watching, and God bless you.